Okay, and here is SOL topic number 3, factors and roots. Let's first look at some important factoring patterns, starting with the greatest common factor, or GCF. You should always look to factor out a GCF first. The GCF could be a number, or it could be a variable, or it could be the combination of a number and variable. It is a unique way of factoring because you are dividing out a monomial and you're left with only one set of parentheses with the factors that remain. Next is the difference of two perfect squares, then the difference of two perfect cubes, then the sum of two perfect cubes. And please note the signs in the factors of these three patterns. If you don't remember to factor, that'll be okay because we do have an app on the calculator, the PolySimul 2 app, that will help us to factor. But remember, the app will only give us the zeros, not the factors. We will have to translate the zeros into factors. So let's look at that. Understanding the relationship between the solutions, roots, zeros, and x-intercepts, and the factor. So for example, if x equals 3 is a solution, then the number 3 is a solution, 3 is a root, 3 is a 0, 3 comma 0 is the x-intercept, but x minus 3 is the factor. Notice that the factor uses the opposite operation. So if you have a positive root, you will see a minus sign in the factor. Another example, if x equals negative 1/7, that's the solution, then the factor will be 7x plus 1. Notice the opposite operation, a plus, and notice also that the denominator is the coefficient in our x. Two other notes. The degree, which is your greatest exponent, is how many total zeros will exist. And if you have any real zeros, they will always occur at the x-intercepts. So let's look at some examples. Example number 1, factor completely. 25x squared minus 4. I will show you 3 ways to solve this problem. First, if you notice that this is the difference of two perfect squares and you can factor that, then you have your answer. If you're not sure about that, or if you want to check, you can take all of the answer choices and multiply them together to see which one yields the original problem. If you have a binomial squared, I might scratch out the squared and rewrite the binomial next to itself, and then I can see my distribution, or FOIL, FOIL. So you could do that. Or the third option, let's pull up our calculator and use the PolySimul app. So if I turn on my calculator and go to the apps button, mine is option number 4, so I'm going to hit 4 for the PolySimul 2. It says press any key to start. And we're looking at option number 1, polynomial root finder. So I will hit 1. Now on this screen there are at least 2 things that are important. The order. The calculator uses the word order for degree. So let's make that note. When we're talking about the degree, the calculator is using the word order. Okay, and since our degree is 2, we have a quadratic, and that's the default. We're just going to leave the 2 highlighted. The next thing, please make sure you go and change into the complex mode, A plus BI. Let's press enter so that we are on the complex mode. Everything else can stay the same, and I'm going to hit the next button, which is graph. Now it's looking for the coefficients of my quadratic. It's looking for 3, but obviously I only have 2 because I'm missing one of the terms. Perhaps we rewrite this as 25x squared plus 0x minus 4. So I can see all 3 coefficients. Let's pull up my calculator. And let's type in those coefficients. I have 25, and then 0, and then negative 4. All I have to do is hit solve, and it will solve the equation for me. Now remember, it's just going to give me the zeros, 2/5 and negative 2/5. Those are not the factors, those are the zeros. So if one of them is 2/5, and the other one is negative 2/5, I know that my factors are going to have opposite signs. So it can't be A and it can't be B because those factors have the same signs. We're down to C or D. This root would correspond to 5x minus 2. And this root would correspond to 5x plus 2. Remember, we changed the sign for the factor, and the denominator becomes the coefficient. So now I know my answer is C. Let's look at example 2. This is one of our TEI questions. We are to click and drag each factor to the box so that we can factor this polynomial, x cubed minus 5x squared plus 6x. So we have these 6 options for factors and we're going to drag them into the box. Well, this is another perfect example that we can use our calculator for. So I've already have my calculator. I'm going to go back to the mode. So I'm going to push that window button. Now this order or degree is a cubic. So we're going to change that to a 3 and highlight the 3. Everything else can stay the same. I'm going to go hit next. And now I'm looking for 4 coefficients. Well, I see 3 of them. I see the 1, I see the negative 5, I see the positive 6. I'm going to put plus 0 at the end so that I can see all 4 of them. So I've got 1, enter, negative 5, enter, 6, enter, and 0. Enter. I'm going to hit solve and it will solve for my 3 zeros. I have 3, 2, and 0. So I've got x equals 3, x equals 2, and x equals 0. Now let's translate these into factors. This would be a factor of x minus 3. This would be a factor of x minus 2. And this would be a factor of x minus 0, of course being x. So my 3 factors, I'm just going to drag them in. I'll start with the x, drag that on in, that's x, and then I'll have the x, there it is, x minus 2, and then I'll drag in, here it is, the x minus 3, and we have our answer. Example 3. A polynomial function has a 0 at x equals 6. Which expression must be a factor of that polynomial? Well, we've got x equals 6, and that, of course, would correspond to a factor of x minus 6. So that's not too bad. That's option B. Let's look at example 4. Which of the following describes the roots of the equation 9x squared equals 6x minus 1? Okay, so the first thing that I'm noting is that this is not in standard form. Let's rewrite it over here. We're going to have to do some math before we begin and use our calculator. All of this should be equal to 0 so that it's in standard form. So the 9x squared is going to stay on this side. I'm going to subtract 6x, so now it's negative 6x. I'm going to add 1, so now it's a positive 1. And now it's all equal to 0. We need to see that it's equal to 0. And then we see all 3 of our coefficients, and I can go back and use my app. I do have to go back to mode and change it back to a degree of 2 because this is a quadratic. Everything else will stay the same. I'm going to hit next. And I've got my 3 coefficients. I have 9, enter, negative 6, enter, 1, enter. I'm going to hit solve, and I'm going to look at my answer choices, or at my answers. I have both of them the same. Both of them are 1/3. So let's look what I have. Answer choice A, exactly 1 real root. Well, 1/3 is a real number, and that's the only number that I have, so that's absolutely the answer. B was 2 distinct real roots. This would mean 2 different numbers. And since 1/3 repeated itself, it can't be option B. And then C and D are talking about imaginary roots. And imaginary roots would use the imaginary unit, the I, and of course that's not in 1/3. So we have our answer. And finally, our last example, number 5, which appears to be a solution of the graph g of x equals 0. Now they've given us a graph. Remember that solutions are the same thing as x-intercepts. So if they give you a graph, you're just looking for the x-intercepts. One of them is there, the other one is there. I've got -3 and I've got 1. Well, which of those is one of our answer choices? I see my first answer choice is -3. That's one of them, and there it is. Thanks for watching this tutorial, and have fun with your packet.